Welcome back. Today we're going to talk about conic sections. So first of all, just kind of scribble on here real quick kind of what this entails overall. So we've got this shape, and then when we cut it, depending on if we cut it across or cut it like that, we create a different shape right there. So this one, cutting straight through the middle like that, we create that kind of shape. In this case would be a circle. Right here we see that slicing it like that would also slice it down here, and that would make a hyperbola if we cut it, something along those lines where we sliced it like this, we would create a parabola. So when I explain this to students, I talk to them about, you just take a samurai sword and you came up to this shape, and depending on how you cut this thing, you would create a different conic section, be it a parabola, hyperbola, or ellipse. So in our memorize sheet, or our study guide, whatever we want to call it, I've put the formulas in an example of what they might look like. If you memorize this, you may come into problems because, there's a lot of information there if you look across all three of them. However, some of this should start making sense based on understanding of how it works. So if we know that our H and K will default to 0 unless we specify otherwise, that will put us at the axes. So this is just like any other transformation. We subtract 2 and move it to, or if we put in 2 for H, then it's going to move it to that direction. And then the distance from the center to a vertices, then we can describe as being A or B away from that point, depending on if we're talking about it opens wide or tall. So when we look at these, instead of memorizing it, we should get to the point where, okay, so if we know that it opens wide, which it does in this case of my example here, then it is going to be A away, because A will be larger, so it will be with how it opens, A away from my center. That there is a distance that would specify that, and it makes sense that it would be A. And then B then would be the other one to go upwards. So instead of trying to memorize all of these, we may be able to just start to come to an understanding. And same thing with like the major axis. If we know that from the center to a vertices is A, well then the whole major axis would be 2A. So I would challenge you to maybe open up Desmos and create a few of these problems. Obviously I'm going to create a worksheet for you if you want to work there, and there's also practice quizzes on it. But get familiar with this to the point where you're not thinking about this via these formulas, but just an understanding of how it actually works. When you guys see these on the Praxis, if you do, there's not very many of them, they're either going to give you the function to start with, or not the function, the equation to start with, and they're going to ask you for certain information, like where's the vertex, what's the directrix, or they may give you pieces of this and ask you for the standard equation. So, to give you an example, if we had a problem where the major vertex, I'm just going to say MV, is, or actually let's do this, let's say major axis length, so MA, is equal to 6, and it's on the y-axis. And then the minor axis, so we're just going to do, well, we'll actually write this one. since we don't want to use m twice. The minor axis is equal to 4, and it's on the x-axis. What is the equation? So if we're trying to find the equation, they gave us this information. Well, if it's on the y-axis, then h must be 0, right? It's not moving left or right if it stayed at the default origin place. And then if it stayed on the x-axis, well, that means that k is 0 because it didn't move up or down. So let's write what we know so far. H is 0, k is 0. And we also see that it is opening tall, not wide, right? It's taller than it is wide. So if we look at this, we know that it's going to open tall. And then this distance will be, let's see here, 6. And across will be 4. So not to scale, but we get the idea. And because, again, because it was the major axis was on the y-axis, it didn't move left or right. Because the minor axis is on the x-axis, it didn't move up or down. So we know that if it's opening tall, or actually we know this value now, so we don't even have to put k, 0. The A is going to be our distance from the center to the major vertices. So if the major axis is 2a equals 6, then a must equal 3. And we can do the same thing for finding b. If the minor axis is 2b, and that's 4, then b must equal 2. So we put 3 squared plus x minus 0 squared over b squared, which is 2 squared, equals 1. Now obviously we could not have the zeros or put a 9 and a 4 down here instead of 3 squared and 2 squared. I'm just plugging in directly into what we know is our standard form, which is this, plus x minus h squared over b squared equals 1. So I'm just plugging in every variable so we can see where it comes from. But the point is, when we're taking the praxis, you may be given this information, something along these lines, or who knows what they're going to give you, but you may have to take this information and create the equation, or you may have to go from the equation backwards, and you can practice that on your worksheets or in the quizzes. And I think we're done with that. Thank you.